In today's lecture, we will learn how to find the area of closed figures and also some loops. Okay. So, if curve is looped around or if let us say curve is completely closed, then how to find the area of that. But in the last lecture, we have learned one interesting technique of curve sketching using calculus and the other ideas of the functions. Okay. So, now in today's lecture, in the problems that we are solving, we will also take help of that technique to draw the graphs if and when they are required. Okay. So, in the last lecture, we were solving a problem. We have learned the graphs. Okay, we have drawn those two graphs and also we were solving this problem. We solved this using pure algebra, but now I will tell you how to draw the graphs of these two functions. Okay. So, that is just out of curiosity, I am just showing you how to draw the graphs. Without drawing graphs also we could find the area under curve, but without drawing graphs, if we directly integrate, then we do not know what area we are calculating. So, you could go wrong, and especially when it comes to advanced level questions, definitely you will go wrong. Okay. So, now how to draw the graphs of these two. So, if I take the first function, so here I am only discussing the graphs. If I take the first function, this has two functions involved. One is x, y equal to x is one function, and the other is y equal to log x. Now, whenever we want to draw the graph of the product of the functions, so what we do is we draw both graphs separately on the same setup. So, this is the graph of y equal to x line and this is the graph of log x. So, if we observe the graph of log x, it becomes 0 at 1 and in the right side of 1 it is positive, in the left side it is negative, and at 0 it is not defined, and before 0, that means in the left side of 0 it is not defined. So, when it comes to the overall graph of the function, what happens is function is not defined for negative values. So, negative values are not in the domain. Okay. So, the entire graph will be only for the positive side, and because at 1, at x equal to 1, one function is becoming 0. So, product of functions also will become 0. So, at 1 we have one root, okay, we observed this, and in the right side of 1 both outputs are positive. So, the result is positive. In the left side of 1, one output is positive, one is negative. So, it has to be negative. So, 1 must be a root. So, there must be a cut here. And further if we observe in the right side, both functions are increasing. So, the product also will increase. So, the graph may increase. Okay. So, it may go like this or it may go like this. It may vary depending on the situation. Okay. And next, in the left side, whether graph will tend to minus infinity here or it will turn back and tend to 0 or not, that we have to verify by checking the value at x equal to 0. But if I put x equal to 0, this function is not defined. So, hence we need to take limit and observe. So, when I take limit x tending to 0, x into log x, you know how to calculate this limit. We take x to LHS and write it as 1 by x, differentiate it and do it. So, here our limit will come out to be 0, which means this function has to turn and it has to go back to 0. But at x equal to 0, definitely it is not defined. So, hence we can take this as the graph. Okay. So, to draw a final graph, let me just take this as the graph. Okay. So, this way we can draw the graph of the required function. Okay. So, I think we have to erase the other option, we have to erase this part. So, our function will be somewhat like this. Okay. Now, further, this is the graph of LHS. What about the, this is graph of first function. What about the other function? To draw the other function, we take these two graphs. Y equal to 1 by x is one graph and log x is the other graph. So, again here also we will observe it in the same manner. this is my graph of 1 by x and this is my graph of log x. So, basically we are multiplying these two functions, and here we notice that definitely negative values are to be omitted because for negative values log is not defined. And here if we observe, in the right side of 1 the output is positive, in the left side of 1 output is negative, that is very clear. And as we approach 0, one value is tending to minus infinity, other value is tending to plus infinity. So, the net result will tend to minus infinity only. So, that means for the final graph we can say that at 1 definitely there is a root and this has to tend to minus infinity here. Now, what about in the positive side? Here if we notice it is increasing very rapidly, but here if we notice log x is increasing, but slowly it is increasing. The rate of increment is low here, rate of increment is very much high here. So, at 1 this rate is actually a dominating rate. So, and also function has to cross x axis. So, it will cross at high pace and it will keep going. But will it stay increased or will it start decreasing? That we will decide based on the limit as x tends to infinity. So, that means we need to observe what happens to the value as x tends to infinity. That also means because one value is tending to 0, other is tending to infinity, we need to identify which is the dominating rate, what is the net result. So, for that we need to observe this rate, limit x tending to infinity log x by x. Now, here as x tends to infinity, x is tending to infinity, log x is also tending to infinity. So, here we can apply L'Hospital rule and observe, and if you observe this limit is actually tending to 0, that means horizontal asymptote exists and that horizontal asymptote is nothing but our x axis. So, graph has to make a turn and it has to approach x axis like this. Okay. So, these two are the graphs. Now, this is one graph and this is another graph. Now, if we want to find the common area, so we have to draw both graphs together and observe. So, one graph is behaving like this, one graph is behaving like this, the other graph is behaving like this. Okay. Now, what will be the common area? Here we can observe that this is the common area and this value is 1 by e and this value is 1. So, basically between these two values we have observed the area. So, here if you notice using this technique we are able to draw graphs of any function. Okay. So, in this function if we notice what are the ideas that we use the most? We use these roots and not defined values, we used signs also, we also took help of asymptotes, we got one horizontal asymptote also, but we did not use this derivative much. Okay. So, in any question you may be able to use all ideas or some of the ideas, but if you master all these ideas then you will master any graph. Okay. So, now we will go to the areas of loops. Okay. So, let us look at one basic question. Here we are interested in finding the area of the ellipse. Now, how do we find the area of the ellipse? First we have to draw the graph, we already know the graph, it is a closed loop, of course it is a closed loop. Okay. And also it is a symmetric loop. So, to find the total area, if we can find any one segment and using symmetry if we can multiply it and get the overall area, it is fine. So, I am trying to take this segment in the first quadrant. If I find this area, I can multiply that with 4 and get the overall area. Now, to find the area, we have to make a choice whether we want to go for area with x axis or area with y axis. If I go for area with x axis, then I may have to use this idea of y dx, because I am taking only the first quadrant and there is symmetry. So, I will multiply this with 4 and get the overall area. Now, what about the function of y? Function of expression for y as a function of x, we have to derive and use it. So, what about that expression? Can we take plus or can we take minus? That depends on the first quadrant. So, let me just get an expression here. So, when I write y, I will get plus minus b into root of 1 minus x square by a square. So, because square root is involved, this value is already non-negative. So, we have to put plus sign outside, but that depends on the value that is here. Okay. So, if this value is already negative, then we may have to put minus sign. Okay. So, here we can write this as 4 into integral of b into root of 1 minus x square by a square into dx. What about the limits? Because integral is happening with respect to x, limits must vary according to x. So, x is varying from 0 to a. So, we can put the limits as 0 to a. Now, how do we solve this further? Of course, we need to go for one trigonometric substitution. So, suppose let us say if I put x equal to a sin theta, you can also put x equal to a cos theta, it does not matter. Okay. So, if I put x equal to a sin theta, so I will get dx equal to a into cos theta into d theta, and limits will be varying from 0 to pi by 2. You know how we got the limits here. So, also we need to check this expression root of 1 minus x square by a square. This will come out to be 1 minus sin square theta under root, and this will be cos theta. Ideally, when we apply square root, we need to put modulus there, but because in these angles, in these limits 0 to pi by 2, cos theta is already positive. So, hence I put plus sign. Okay. So, that means here we can write this as cos theta into, in place of dx I will put this a into cos theta d theta. Now, this is coming out to be 4ab into 0 to pi by 2 cos square theta d theta. To integrate this, we can write cos square as 1 plus cos 2 theta by 2, or we can also use the reduction forms. So, what do we get directly here? By using reduction forms, we can get this as 1 by 2 into pi by 2, hence we got the area as pi ab. Okay. Okay, so here after we wrote an expression, we went for the integration, and integral came in terms of theta, we could use reduction forms. But instead of going for directly this kind of substitution, you can also go for the standard parametric form of ellipse. That means x equal to a cos theta, y equal to b sin theta, you can put it, and also you can try to solve this, you will still get the same answer. Okay. Come on, make a note of this. Okay. Can we move on to the next question? Next is this question. So, here there are actually two confusions in this question. One is that we have inequality which is less than equal to, and the other confusion is the modulus sign. So, we will deal with them separately one by one. Suppose let us say we go for the inequality. Whenever in any chapter, in any question, if you have the inequality case, you first explore the equality and then try to move either in the right side or left side of the inequality and observe what happens geometrically. This is how to handle the inequality. So, basically here I am going to take equality first, and then I will observe what happens if I move away or inside. Okay, we will check that later. And now, to handle modulus, you need to recall all properties of modulus, but look at our algorithm of drawing graphs. What is our first step? Check symmetry. Now, here if I put minus x in place of x, will the equation change? Of course, no. So, that means graph is symmetric about y axis. Next again, if I put minus y in place of y, equation is still not changing. that means graph is symmetric about x-axis. Because there is now 2 degrees of symmetry, if we can draw only one part, we can reflect it to get the other 3 parts also. So that means basically I am going to draw the graph in only first quadrant, and then I will see what happens, and based on that I will draw the other parts also. Okay. So suppose here if I take x positive and y positive, so what do I get algebraically? This equation will give me 3x plus 4y equal to 12. You know how to draw this line. So we will get 3 units as y intercept, and we will get 4 units as x intercept, and we will get a line like this. Okay. Now can we take these 2 parts? No, we cannot, because we assume that the values are in first quadrant. So even if we get one part which is outside first quadrant, we have to delete it. So the graph for this is only one line segment. It is not line, it is only line segment. Now because there is symmetry, we can reflect this. So there is symmetry about y-axis. So I will reflect this about y-axis, and again there is symmetry about x-axis. So I will reflect both parts about x-axis, then I will get a graph like this. So this is the required graph. Now we need to again understand whether the area is enclosed or outclosed. We have to understand that. So to understand it, we have to check what happens if I put 3x plus 4y less than 12. So you know how to handle this above line and below line. I have explained this in coordinate geometry also. We write the function as y equal to f of x and see if y is greater than f of x or less than f of x. So here y is less than f of x. So we are talking about the below this line. Okay. So that means below this line. So same if I apply for the other cases also. So we are talking about the interior of this rhombus. Now how do we find the area? To find the area, do we need to use integration? Of course not, because this is a simple diagram. So either I can find this area of this triangle and multiply that with 4, or I can use the formula of area of the rhombus. So here if we notice, this is 4 units, this is also 4 units. So this total is 8, this is 6. So area is going to be half d1 d2, so half into 6 into 8, which is 24. This way we can solve the problem. Okay. But here if you notice, there is symmetry, there is inequality. You should know how to handle them in any situation, any case. And in the other case, on the other hand, what we have here is the idea of not using integration. So what are the functions which actually compel us to not go for integration? Modulus function, greatest integer function, and fractional part function. These are the special functions which actually give us questions without integration, give us answers without integration. So that is why whenever these functions come, try to rely mostly on the graphs. Okay. Come on, make a note of this. Okay. Now we will move on to the next question. So next question is, find the area given by a curve like this. So here box means it is greatest integer function. This statement is not mentioned here, but in the exam if it is not mentioned, you have to understand that those are simple brackets only. So in the exam, if it is greatest integer function or fraction part function, the person who set the question paper must have mentioned, it is the rule. If it is not mentioned, then benefit of doubt goes to students only. Okay. So now let me just solve this question, because if we notice both boxes, that means both are integers. So we need to look for the product of integers to be always 3. So what are the possible cases? Let us list down the cases here. We have box of x here and we have box of y here. Now if box of x is 3, box of y can be 1. If box of x is 1, box of y can be 3. And we can also get the negative cases. So, total 4 cases are possible here. We got less number of cases because we took 3 to be a prime number. If it is not a prime number, we may get more number of cases. Now, how to attack the problem? In 99% of the cases, if you just attack only one case, then into 4 will be your total answer, because there are total 4 cases. So, let us just take one case. When box of x is 3, x will be belonging to closed interval 3 to open interval 4. Similarly, when box of y is 1, x will be belonging to closed interval 1 to open interval 2. So, where will this situation be on the graph? Let us take x axis, y axis, and let us scale it up. 1 here, 2 here, 3 here, 4 here. Similarly, 1 here, 2 here, 3 here, 4 here, let us say something like this. Now, x must be belonging to 3 to 4. It could be equal to 3, but it cannot be equal to 4. So, it could be equal to 3, it cannot be equal to 4. So, I am keeping a hole on 4. Similarly, here it must be between 1 and 2. It could be equal to 1, but it cannot be equal to 2. So, I will put a hole here. Now, if we combine this area, what is the area that we will get? We will get this line completely and also this line, but other two boundaries we will not get. We will get an area like this. Now, similarly for the other cases also, if we draw diagrams, we may get diagrams like this. And similarly here also we will get similar such diagrams. We may get one diagram here and we may get one here. Okay. And each part looks like a square, but we do not have two boundaries. Okay. But just removing boundaries will not change the area. So, area of this square will be, because sides are 1, 1, area is 1. Similarly, for all 4, the area is 4 units. So, that way we can solve this problem, but this is also purely based on graph. As I said earlier also in earlier question, if it is involving box function, then it is definitely graph based question. Now that I have discussed the ideas, let me give you few more problems on this for your homework. You can try these questions. Box of x plus box of y is equal to 3. What happens to this? And here take x to be positive, y also to be positive. Now another, let us say x plus y is equal to box of x into box of y. Try this one. And also x plus y equal to box of x plus box of y. You can try these ones also. So, try to solve questions like this and try to gain grip on this. Okay. Come on, make a note of this. Okay. Can we move on now to the next question? Okay. Next, find the area bounded by this graph in the with the coordinate axis. Now, before we go for that, again our first step should be to go for the graphs. So, here to go for graph we need to also check the domain first. Now, if you notice there are square roots involved, that is why I am talking about domain, otherwise generally we do not go for domain. So, but ideally your first step should be to go for domain. Here we observe that x should be non-negative, y also should be non-negative, and the maximum value for x could be only a. So, x must be less than equal to a, y also must be less than equal to a. Of course, this is symmetric about y equal to x line, because if we swap x and y, algebra remains same, that is why it is symmetric about y equal to x. Now, is there any symmetry about x axis, y axis? Of course, graph does not exist, so there is no symmetry. Okay? Graph does not exist for the negative side of x axis and negative side of y axis also. So, graph comes only in the first quadrant. So, I will just draw first quadrant here. Now, 2 points we can easily make out. What are the points? If I put x equal to a, it satisfies. So, a comma 0 is one point. If I put y equal to a, it also satisfies. 0 comma a is another point. Now, because square roots are involved, definitely this is not a straight line graph. So, it could be either this type of graph or this type of graph. We do not know what it is, but we do not care, because we are interested in only the area formed with coordinate axis. Whatever is the curvature, we do not really care. We can directly find the area by blindly integrating it. Okay. So, suppose let us say I go for blind integration. So, here we get that root of y equal to root of a minus root of x. I will just get an expression for y. So, here y will come out to be a plus x minus 2 root a into root x, and the area is going to be 0 to a y dx. Now, what is y here? A plus x minus 2 root a into root x into dx, going from 0 to a. So, let me just get this integral. Here we get ax plus x square by 2 minus 2 root a into x root x divided by 3 by 2, going from 0 to a. Now, further when we simplify, what do we get? A square plus a square by 2 minus 2 root a into a root a into 2 by 3. That is it. So, if we simplify, what do we get? If I take a square common, here I am getting 3 by 2, here I am getting 4 by 3. So, this will give me a square by 6. So, area is a square by 6. We got this directly without actually getting the accurate graph, but we got rough graph. Suppose let us say you are interested in actually knowing which is the correct graph. How do we check that? Just take this line by joining these two. This line is going to be x plus y equal to a, right? Now, on this line, take any point which is somewhere in the middle. Okay. Suppose let us say I take the midpoint, which is a by 2 comma a by 2. Okay. Now, for the curve, if the curve is below the line, that means point should be above the curve. So, let us substitute it here and check and compare these two. Just compare these two, whether they are equal or less than or greater than. So, let me just put a by 2 and verify. So, here I am getting root of a, and here minus root of a by 2, and here this is root of a. So, let me this is root of a by 2. Now, let me just check. It becomes root of a into 1 minus 1 by root 2. Now, we have to only check whether this is actually greater than root a by 2 or less than root a by 2. So, this is going to confuse you more. Instead of this, let us verify this. Root of x plus root of y, this will come out to be root of a by 2 plus root of a by 2, which will give us root 2 into root a. This is definitely greater than root a. So, that means this is going to be definitely greater. Greater means point is above the curve. So, that means this is the right option, this is the wrong option. Okay. If the point came to be below the curve, then that means this is the right option. Okay. So, here we got an idea of how to generate the graph also. Okay. Come on, make a note of this. Now, let us solve another problem. This problem is an interesting problem. So, here the question is about finding the area within the curve. Now, this curve is going to give us a loop here. Now, what exactly is the curve, that we will see. Of course, this will take lot of time because I am going to explain you its graph also. Okay. So, now let us make a choice. Do we want graph with graph or without graph? Let us check without graph first, then we will go for with graph. Suppose let us say, okay, this is the wrong way of doing. So, I will just explain you the wrong way. Okay. This is pure algebra. Suppose let us say I write y equal to something. So, if I break this up, I will get y equal to plus minus x by a into root of a square minus x square, right. Now, if I assume that this function is in the only first quadrant, then I will still not get any idea of the graph. But still some students might go for this blunt way of doing it by integrating this from 0 to a y dx. But doing this will not actually give you any clarity. But some students may even try using this idea that this function is going to be symmetric about x and y axis, and then they will try to multiply this with 4 or something, but that is actually a bad way of doing it. Okay. So, here I have just spoken what not to do. Let us now discuss what to do. So, as I kept saying from earlier cases also, using blind integration you can also get the area, but you are not sure about what exactly is the correct area. So, hence do not do that. Okay. So, always go for the graphs even if they take time. If you practice well, you will master the curve sketching technique. Then in the exam, drawing graph will not take more than 30 seconds or maybe more than 1 minute. It will not take. Okay. So, now let us check all our checkpoints here. First, what is our first step? Check the symmetry. Now, if I put minus x in place of x, equation remains same. So, graph is symmetric about y axis. Okay. Next, similarly, if I put minus y in place of y, graph is symmetric about x axis because the equation does not change. So, graph is symmetric about x axis also. Okay. Next, second, what is the next step? Roots and not defined values. But before that, let me just check the domain first. Here LHS is already a non-negative number because it is a perfect square. So, RHS also must be non-negative number. X square is already non-negative. So, hence a square minus x square must also be non-negative. So, a square minus x square must be greater than equal to 0, which will give us values of x to be belonging to minus a to a. Okay. That becomes our domain. And we also are interested in checking what are the roots and what are the not defined values. So, here we observe that x equal to 0 is a root. When I put x equal to 0, y becomes 0. Also, when I put x equal to minus a and plus a, y still becomes 0. So, x equal to a and x equal to minus a are also roots. Now, because here from the first point if you notice, because there is already symmetry, if I draw only the graph in the first quadrant, it is sufficient to get the other parts also. So, what I will try to do is, I will take only the graph in the first quadrant. Okay. So, basically these are our checkpoints. So, we are still standing here. Okay. So, let me take the graph here only. Okay. So, this is my A, this is the 0 and this is let us say minus A. Okay. Okay. Now, I am drawing only graph in the first quadrant. So, at 0 the output is 0, at A also output is 0. So, we got 2 points. Okay. So, what are those 2 points? 0, 0 and A, 0, these are the 2 points we got. Okay. Next, what is the checkpoint? Signs. To get the signs we have to write y. Because we are in the first quadrant, x is positive, y is also positive. So when I take the square root, I can straight away write this as x by a into root of a square minus x square. So now everything is positive. So we assume that all signs are positive signs only. Okay. So it's all positive in the first quadrant. Next, asymptotes. To get the vertical asymptotes, check if there is any value which will give us 1 by 0 form. There is no such value, no vertical asymptotes. To get horizontal asymptotes or slant asymptotes, function has to be defined for indefinitely till infinity and minus infinity, but this is getting limited at a and minus a. So these two also don't exist. Now this fourth point has actually deserted us, because in the earlier questions, in most of the cases we handled the entire function based on the asymptotes and signs only. So here signs have deserted us because it gave only one sign. Asymptotes also deserted us. Now let us go for the study of derivative. So if I differentiate this directly using implicit differentiation technique, so what will I get? I get a square into 2y dash is equal to 2x into a square minus x square plus x square into minus 2x. Now if I simplify this and cancel out 2 also, so I am going to get x into a square minus 2x square. So y dash can be written as this divided by a square into y. So now this is our derivative function. We can also write this as, by using this expression, we can also write this as x into a square minus 2x square divided by a into x into root of a square minus x square. Now I did not cancel out x here because x equal to 0 is a perfectly defined value for the function. We got the 0 by 0 form here because I wrote the function in this form, because I wrote the derivative in this form. So there could be an ambiguity at 0 comma 0. There could be an ambiguity of slope at 0 comma 0. So that is why I just wrote it like this. But if I am assuming that x is not equal to 0, I can cancel it out. Okay. So let's assume temporarily that x is not equal to 0. So if x is not equal to 0, then I'll get y dash as, I can take this to the next page. Okay, no. So I can get y dash as a square minus 2x square by a into root of a square minus x square. Okay. So I got the y dash here. Now I'll study this y dash separately here in this page. What are the cases that I am checking? F dash equal to 0 is the first case. Now let me just check that. F dash equal to 0 will give me x equal to a by root 2 and minus a by root 2. This I am rejecting because I am looking for only values in the first quadrant. So a by root 2 will be somewhere here. Okay, a by root 2 is somewhere here. Here the derivative must be 0. Also to get the point at a by root 2, let me substitute this in the function and check the value. Okay. So if I put a by root 2 for x here, what do I get for y? So let us just put a by root 2 here. It will give me a square by 2. A square minus a square by 2 is a square by 2. Here also I will get a square by 2. A square will get cancelled. So I am getting y as a by 2. Okay. So that means this here the point will be at a by 2. If this much length is a, so half of it will be somewhat like this. So this is my a by 2. Okay. So at this point derivative must be 0. That means tangent must be parallel to x axis. So I have drawn simple slope diagram like this. Okay. See this idea, you will use this idea in engineering also. Based on slopes we mark like this and we can draw the entire graph using such marks only. Okay. but temporarily I am just giving you for only one point. Now let us look at this once again. F dash is not defined. Is there any value which will give me f dash to be not defined? See, observe here, when x is equal to a, the derivative becomes 1 by 0 form. So which means, this is the other case, f dash is giving us 1 by 0 form at x equal to a. This means tangent is parallel to y axis. So that means here we will get one tangent like this. Okay. Now let me check at 0 again, once again. At x equal to 0, derivative is not defined because of the 0 by 0 form. So whenever you get 0 by 0 form in the derivative, remember that there is an ambiguity. It is not the tangent parallel to y-axis, no it is not, it represents ambiguity. Why is the ambiguity there? That I will explain little later. Now what if it is tending to 0? As x tends to 0, f dash is tending to. Observe here, if it is not equal to 0, I can take this expression. So if I put x equal to 0, I am getting 1 as the derivative, which means at 0 there is an ambiguity, but after 0 in the positive side the slope must be 1 unit. Okay. So the graph must, so the tangent must be somewhat like this. Now by joining these ideas, if we draw the graph must be only in the positive region, it has to increase initially, derivative becomes 0 here, after that it has to decrease, and here tangent is parallel to y-axis, so graph must become vertical here. So what will be the kind of graph that we will get here? We may get a graph like this. Okay. This is the graph. We can also observe monotonicity using these ideas. But we already got the sufficient information, so I am progressing. And similarly, for the negative side, we can just reflect it and get the graph. So for a by root 2, we may get a point somewhere here. So here also graph may be somewhat like this. Okay. And again it is symmetric about y-axis also. So similarly for the other case also we can get the graph in the similar lines. Okay. This is our graph. Okay. So it looks like a dumbbell shape and this is a good graph, this is a beautiful graph. In fact, you can also work out a relation for the graph of heart. Okay. You can also work out graphs of heart symbol or any symbol you can generate graphs. Okay. But that I am giving you as homework. Okay. If you are interested, you can try those graphs also. Now there is this graph. So we have drawn everything, we have converted every data that we got into this graph. But there was one confusion that I am explaining now. What was the confusion? This was creating ambiguity. Now what is the meaning of this ambiguity? Here at 0, when we differentiate, if there is only one curve, it will give us a slope. But here there are two branches of the curve which are intersecting. So that means derivative is ambiguous here. It will not give you one particular value. Because if you are following this curve, you must have got 1 as the derivative at 0. But if you are following this curve, you must have got -1 as the derivative. So because both are possible, there is an ambiguity. Now this ambiguity is similar to this idea of d by dx of mod x at x equal to 0. This ambiguity and this ambiguity are actually same type of ambiguity. Okay. So this is the general knowledge point. Okay. So I have just explained you the general knowledge point. Now going back to the area. we want to find area within the curve. So here luckily the curve came out to be with two loops. We can also sometimes get curves of this kind where we are getting curve but there is only one loop. These kind of graphs are also possible, okay. But in this particular situation we got only complete loops. Now, how do we find the area? If we just find area of this segment and multiply that with 4, we can get the overall area. Okay. So, how do we proceed with this? Starting from 0 till a, if we integrate the function directly, we can get the area. So, integral of y dx going from 0 to a and multiplying this with 4 will give us the required area. Now, how do we integrate this? That is simple. We just write the expression and integrate. So, 0 to a. What is the expression for y that we got earlier? It was x by a into root of a square minus x square into dx. Can we directly integrate this? Of course, yes. Can we not substitute trigonometry? We can also do that, but it is your choice. So, I will substitute trigonometry. You can also take x square as t and try to do this. I am using trigo because I know the reduction forms. I can get the integral very fast using reduction forms. So, let me just put x equal to a sin theta, then that means dx will become a cos theta d theta. So, this will come out to be 4 into 0 to pi by 2, x is a sin theta, so this becomes sin theta. And what about this a square minus x square under root, this will give me a into cos theta. So, here we basically got a cos theta, and in dx also there is one a cos theta d theta. So, we got basically a square outside, and this integral did not even go for reduction form, it came as derivative of the other. So, we can directly write this as 4a square into cos cube theta by 3, limit going from 0 to pi by 2 with one extra minus sign. Okay. So, now further how do we do this? So, minus 4a square into, if I put pi by 2 by 3 into pi by 2, it becomes 0 and minus 1. So, answer is 4a square by 3. Okay. So, this way we can integrate. So, now you might be recalling that blind idea of integration. If we had integrated directly in the first quadrant and multiplied with 4, we could have got the same answer, but there is no guarantee that loops are actually formed like this. What if loop was somewhat like this, it was on y axis, or what if there was no loop at all? So, we do not know. That is why it is necessary that you draw the graph first. Okay. So, I hope you are liking these techniques. Okay. Come on, make a note of this. This page also. This page also. This page also. Okay. So, now can we move on to the next question? Next question is this: find the area bounded by these two branches and this line x equal to 1. So, what is our first step? Again, we go back to the same fundamentals. Is there any symmetry? So, here there is no symmetry for this curve. Next, we go for roots and not defined values. Are there any values which are actually serving as roots here? One is, you can take x equal to 0, this will give us y also to be equal to 0. Okay. if we take x equal to 1, if we take x equal to 1, y also may become 0, not, we do not know, we will just see that. Now, LHS is already a non-negative term. See, this is called as qualitative analysis of the algebra. Always we should be analyzing signs and validity of the equation given. LHS is non-negative, RHS must be non-negative. So, hence x must be positive. So, here we got one point only. Okay. So, we got only 1.00. So, let us explore points little later. Now, second, x must be positive. If x is positive, then we can go for blind square roots. So, if I take square roots directly, I will get two cases. One is y equal to x plus x root x, the other is y equal to x minus x root x. These are the functions. And because I already got one point which is 0, 0, I can also go for blind integration here. So, blind integration can happen somewhat like this, integral 0 to, what is the value till which we have to integrate? 1. We have to subtract one function from the other and we have to integrate. This way also we can get the area. So, let me just explain it here using blind algebra. So, 0 to 1, what is function 1? It is x plus x root x, second is x minus x root x. What is the difference of these two? It is 2x root x dx, integrate this. So, what do we get? 2 outside x power, this is already 3 by 2. So, 3 by 2 plus 1 by 3 by 2 plus 1, limit going from 0 to 1. Now, when we simplify this, what do we get? Here we are getting 5 by 2. So, which means 2 into 2 by 5 into 1 minus 0. So, we will get 4 by 5 as the area. But now, let us check if geometrically this is right or not. Okay. These type of ideas you may use especially in CET exams, MSET or any other CET exams you can use these ideas, but not in mains and advanced. In mains also up to some extent it may work out, but in advanced definitely it will flop. Okay. Now, let us observe the graph and then see what happens. So, there are two cases here. This is one case, this is other case. Now, how do we draw the graph here? To draw the graph, we have observed one point, we also understood that x must be greater than 0. So, there is no graph for the negative side, we also understood that there is one point here strictly. Now, let me observe the derivative and see what is happening to the derivative. So, for first case, if I go for derivative, I will get 1 plus, here what do we get? 3 by 2 into root x. Now, this derivative is strictly positive. So, first function must be strictly increasing function. Next, for the second if I take derivative, I will get 1 minus 3 by 2 into root x. So, from the beginning only this derivative is definitely less than the above value. So, this is increasing, but it is increasing slowly initially. Okay. So, from 0 when it starts it may increase slowly. But we can understand that this derivative could be 0 also at some point. So, when we work this out we get root x equal to 2 by 3, which means x equal to 4 by 3. So, there might be a value here which is 4 by 9. So, 4 by 9 at which derivative is 0, and also we can observe that this function may also become 0 at one value. See here, if we observe by substituting 1 our output becomes 0. So, 1 comma 0 is a point which is not on one branch, but it is on the other branch. So, at point 1 output becomes 0. So, our second branch is going to be somewhat like this. It increases initially till this value and then it falls like this. Okay. And we are looking at the area bounded by these two till this x equal to 1 line. Okay. So, let me just redraw these two. So, here we have a graph like this, and till here we are basically finding this area. Okay. This is the area that we have just calculated. which accidentally came out to be true. Okay. So, when we execute blind algebra, whether it is going to be true or not, it may depend on your situation and also it may depend on your luck. Okay. So, here if you notice, here also we are using those ideas only that we have discussed in the curve sketching algorithm. Okay. So, with this we close today's lecture. I hope you guys are enjoying these techniques and ideas. We will meet again in the next lecture with new ideas. Until then, have a great learning day. Learning shall never stop.